Okay, so for 7.4, we're going to be looking at standard form. Now, standard form is a pretty compact unit. So what we're going to be doing is breaking 7.4 into a part 1 and a part 2 video. And this is going to be part 1. In this video, we're only going to be looking at writing numbers in standard form. So let's jump right in. So what is standard form first and foremost? Standard form is really just a convenient way of writing really big numbers and really small numbers. Okay, it's on your calculator. You might see on your scientific calculator, or sometimes in a science called scientific notation. It's a way of just abbreviating the number and writing it as a power of 10. Now, if you want to grab your calculator real quick and type in 8 to the 27th power. Now, as you might imagine, that's a pretty big number, and your calculator might generate something looking similar to what you see on the screen. Now, why is that? Now, 8 to the 27th power, as we said before, is pretty big. Your calculator cannot display all the decimal or all the numbers within that final answer, and therefore it abbreviates it and writes it as a power of 10. So you see 2.1475169 times 10 to the 24th power. Can imagine, pretty big. All right, so we're just going to do a quick revision on multiplying and dividing by powers of 10, because this is going to help us and set the groundwork for writing numbers in standard form. All right, so let's get to it. What is 3 times 10 to the 4th power? Now, if you remember from video 7.1, 10 to the 4th power is really 1 with, and that index tells us how many zeros are in that final answer. So it's really 1 with 4 zeros, which is 3 times 10,000, which is just 30,000. Very good. Let's put that comma right in there. And 3.27 times 10 to the 3rd, 1 with 3 zeros. Very good. Which gives us 3270. 3,270. Now let's look at a few division examples, and that's 3 divided by 100, which is pretty simple mental math, 0.03. And this is 4.32 divided by 10,000, which is really 0.000432. Very good. Let's get those final answers nice and neat. Very good. So we have revised the multiplying and dividing by powers of 10. Now let's try to take a look at what standard form really is and how do I write a number in standard form. Now, following the definition from the textbook, a number is written in standard form if it's a times 10 to the power of n. However, that number a must be greater than or equal to 1, but must be less than 10. And n must be an integer. And if you're not familiar with what an integer is, and put a little definition right there, an integer is a negative or positive whole number or 0. Okay? All those numbers are integers. So we're not talking about fractions or decimals. We're only accounting for the negative and positive whole numbers and including 0. Very good. So let's try to see if we could write these numbers in standard form. Now let's take a look at example 2a. 5,720. So the first thing you want to think about is you have to put in a decimal point that is going to create a number that is between 1 and 10. But it must be less than 10, of course. So where would you put a decimal point in that number to create a number that is between 1 and 10? Of course, you might want to put the decimal point right. Let's get that writing right there. Very good. So you're ending up with 5.72. Do I need to write that extra 0? Does it really affect anything? No. So I'm going to omit that and keep it nice and clean. So it's 5.72 times. Now you have to think about it. It has to be written with a power of 10. Now, what power of 10 is going to go here so that when I finish the expansion, like I did in my revision, when I finish the expansion, I get 5,720. Now, if you think about your decimal point being here, you need to get your decimal point out here. So what power of 10 would I multiply by? Hopefully you can see that I need to be multiplying by something in the thousands, and therefore that is 10 to the power of 3. So 5.72 times 10 to the third power, or 10 cubed. All right, good. Now let's look at 7.4. Now this seems to be a tricky one, because do I already have a number that is between 1 and 10? Is 7.4 already between 1 and 10? It certainly is. And therefore, what more do they want? What more could I write that's going to put this number into standard form? So I know the 7.4 is correct, but like it says in the definition, I must write it as a power, or with a power of 10. So 10 to what power is not going to change my answer. What will not change 7.4 from 7.4? That's if I multiplied by 1. But how could I get 10 written with an exponent to give me 1? Now, I'm not sure if you remember from the 7.3 video that any number raised to the power 0 gives me an answer of 1. So 10 to the power 0 is really 1, and 7.4 times 1 is really just 7.4. But you've definitely written it as a power of 10, which qualifies that answer to be in standard form. I hope that one is clear. Good. So let's move on to 473,000. So where does the decimal point need to go in 473,000 to create an A value that is between 1 and 10? So let's try. If I put that decimal point right there, I have 473, and that's certainly not between 1 and 10. If I put it here, no, that's 47.3. That is not between 1 and 10. So that decimal point must certainly go right there to create the number 4.73. Good. Now, what power of 10 do you need to multiply by to get 473,000? 10 to what power? Okay. Now, you could do a simple movement to see how many times you'd have to move to get to the end of the number, which is 1, 2, 3, 4, 5, which is really 10 to the 5th power. And you can always double check that by doing an expansion like we did in the revision. All right. And now we have 6 million. Now, I'm not sure if you know this, but that should be one that comes to memory, or you know from memory, because any number in the million is really a number 10 to the 6. Hopefully that one is clear enough for you. Or if we wanted to go with our conventional way that we have been doing the other 3 examples, where do I put my decimal point to create a number between 1 and 10? I'd have to put the decimal point there. And of course, what power of 10 do I need to multiply by to get the answer? Very good. All right, so now we're looking at 0.09. Now we have a decimal number to begin with. Okay, so when I multiply by that power of 10, I have to ensure that the power of 10 is going to give me a number smaller than what I started with. Okay, let's look at how we're going to go about this. Where does the decimal point need to go first and foremost in order to create a number that is between 1 and 10? If I move the decimal point here, that gives me 0.9. And 0.9 is actually less than 1. So that's not where the decimal point is supposed to go. But if I move the decimal point right there, then of course I get a number that is between 1 and 10, because that is the number 9. So it's 9 times. 10 to what power is going to give me a decimal number that is less than 1. Now, I'm not sure if you remember our fractional exponents. Does anyone remember that? Hopefully we do, because a negative exponent is really us dividing by that power of 10. Good. So what power of 10 would I, in essence, divide 9 by to get 0.09? That is the power 2. Very good. Okay, great. So now let's look at this one. 0.00621. Now, I want to point something out here. Whenever we see a decimal number that is less than 1, all flags should go up in our minds to tell us that the power of 10 that I'm multiplying by should be negative, because I'm in essence dividing a whole number by a power of 10 to get the decimal that I have. So, just want to bear that one in mind. The power in the power of 10, the exponent or the index, has to be negative. All right, so let's go forth. Where do I put that decimal point to create a number that is between 1 and 10? Decimal point has to go right there, giving me 6.21 times 10 to the, I know it's going to be, like I said before, negative. Very good. So what power of 10 am I dividing by? Because multiplying by a negative power of 10 is in essence dividing. What power am I dividing by really to get 0.00621? Let's think about that. Hopefully you came up with 10 to the negative 4. You want to see how many times you have to move your decimal point back or forward to get the number to the number you started with. Okay, now this is very new, so I want you to give your best shot to the exercise that you're doing. And if you'd like some more information on how standard form is used, there's a very interesting website, The Scales of the Universe 2, and the URL is right below. So please feel free to go on to that website and look at how different things are represented in standard form. Hope it was clear enough for you, and I hope you're looking forward to video 7.4 part 2.